Sorry about the noise and all that. Let's just explain this. So, bed, okay, works well. There's no vibrations even when going slow. I don't feel any vibrations. Hot end system, no vibrations, moves along. I can go quick. Now, right off the bat, let's start this. So, first things first, I'm going to show you guys my probe offset. Okay, I'm not going to change this whatsoever. Just because why? Why? Why should I? I already know it's at 0.20. Great. So, this is also added to your homing value. So, as an explanation, just quickly before I get into anything, very simply, we're just going to home the printer, get it to touch down. I do have a CR touch. I also have firmware specifically for printing faster. It is not Clipper. I do have a Raspberry Pi there. I only use it to view. So, basically, just gonna have it touch down so you guys can really get to the bottom of all the printing. Okay. Now, I leveled my x-axis to my frame directly in the center to there. There's 2 screws at the back that you could loosen, mess with that, but trust me, I'll get another video out for that. Now, if we go over to the move portion, you'll notice 11.71. Now, if we were to go into baby steps, negative 1.71, so it lifted it up to theoretically go to 0, pretty much. Now, let's run this. Because my printer's fast, it's quite capable of doing this. I'm just going to make sure that you guys understand. I'm not changing anything. I'm just having it go. This is PETG as a reference. 90 degrees Celsius bed. I will actually keep my enclosure open for this test so that it's more accurate to the general public, basically. Just so that you guys understand what exactly is going on with your printers. And this is any printer, really. This is really any printer. So, I'm just gonna leave this on so you guys know I'm not, like, doing anything to my printer or anything. This is just straight up. Yes, you could say, your hot end system has 4 cooling. This profile specifically has also been tested on stock profiles and stock printers. The only upgrades were single aluminum extrusion extruder. So basically, you could basically do this at no problem on a stock printer. It's more or less how you get to these values. Wow, my printer vibrates. Okay. Still heating up. Sorry about the wait, guys, but, you know, we do what we gotta do, right? Could also notice I cut my bracket. That's when I made my own shroud and messed things up, but that I'll get to later on, too. That's like firmware and how you create your own firmware and how you're getting these printers to actually run the way that you want them to run. And constantly, you want to push print and get it done and over with and not have a problem. This is how you guys do it. Whether you like it or not, this seemingly is how I print every time. And I don't really have any issues. I have multiple spools of all sorts of materials too. This PETG, and then we end up with my other specialized ones, or the one that's in my filament dryer. basically food dehydrator up there in a Bowden tube just going down. I took off my bracket because why? I'd rather have dry filament. So basically we're over here, we're doing this, we're almost at the temperature, and we're gonna just let it go. And you're gonna notice it's very fast. I'm not trying to print slow here. I'm trying to get things done and over with. As many things as possible that I possibly can throw out, basically. It doesn't really matter. There's a whole bunch of things. There's all sorts. It doesn't really matter. You got mini parts, small parts, big parts. It doesn't really matter. Bigger parts come out most times a lot quicker than small parts. But we're gonna get through this. You can see too, I haven't touched anything in this. It was at 0.00. Now it is at negative 1.71. That's what I set it to, using feeler gauge. So basically I just moved the axis down with a 0.00 millimeter offset just to make sure that it's zeroed out, and then I brought the head down to where it says 0.00, but it really isn't, because wherever your stop point is really your 00 point, and I'll explain that right now. The probe has its own 0, and you have to set your Z offset, and even with an end stop. So 0, and then 0, but that's not actually 0. And that, I think, is the whole point in this, is that's not actually 0, and we need to offset it to the actual nozzle position where it should be. So let's state, okay, that we can find 0.20, okay, you can see it right there, 0.20, okay. So because we know that we have 0.20 feet with a feeler, we know that we can set our Z offset to there. So this is 0.20. Just get it touching over it, really. At that point, you could just have your printer go. I'm having this function right now. Is kind of like an AI. It loads your mesh and then tilts it. So when you load a mesh, it's actually just the plane, like all the warps and everything, maybe tilt, and it tries to zero it out. It'll move the Z-axis up and down, very simply. It's like having an AI, pretty much. At that point, it's going to auto heat itself, and we're going to basically attempt to print the same objects as before. These little things, they're just tiny little ball things that I made. It's a 3D model. Anyway, if you want, it doesn't really matter. Just clean off this. It won't matter by the end of this because of how this all works. Let's say you can't even stick, right? Some people, I see that all the time. I can't stick, or yeah, but if I lift it up my Z offset, suddenly nothing works. Okay, find that 0.20 spot. It doesn't matter if you don't stick. We're going to calculate that out with flow. And flow is very specific because that filament gets fed through the system and out that nozzle, which is a 0.4, and that is a 1.75. Think about the calculation in a percentage. If I constantly feed that filament through, what percentage is actually needed in order to get a good extrusion? Really, that's it. So right here, it's almost heated. There we go. It's gonna bounce up. It's very normalized. And there we go. So I'm not even gonna touch this. And you can see my flow is at 100% and speed is also at 100%. But you're gonna notice that I don't print slow. I print very fast. And at this point, I'm gonna jump over and print. Now, what's a bit funny to me is if you're sending a good amount of flow, this in itself should be very possible, and you won't have to do very much, and you're just going to have to dictate how much flow to constantly send over a period of time. So in 3D printing, the process of flow is actually being pressed due to the extrusion. The amount of plastic that you are extruding, it's kind of like injection molding in a different way where your injection head moves. Now, you can instantly see how I can just print. My infill is good, and you're going to notice something too, because as I print this, it's not really a normal object, really. And all of you guys could have as many prints as you possibly want at such a fast rate of speed. I mean, it's 14 minutes. It's a sphere test. It's going to print a sphere on top of that. Now, it's small, so the layer heights have to be perfect, and quite frankly, it has to be pretty good. And I print fast, so I'm not looking for any errors or anything in my axis or the bed or the rollers or anything. And I even have my own silicone that I made in order to stop the ringing. Because I see so many times that people have ringing when going fast and stuff, and I sell them because they work. And I don't have to level because it's fine. So, if your flow is good, you can retain your flow. Retaining flow is seemingly all that the flow does. And I could do this a million times over. I could stop the print, tell it to print, and it'll go there, do its line, go and do the print, and have nothing wrong. This is what you all want in your printers. Now, I'm printing at 280 degrees Celsius at 90 degrees Celsius bed for PETG. I'm even using fan. I don't have stringing. Maybe a minor one that gets burnt off literally every second. But what's that going to do to my print quality is really minor. But now, I'm printing fast, so of course you gotta understand that too. Where if you're printing slower, this should be a lot easier. You can make instant overhangs, no problem, but you must have the right amount of flow. Otherwise it just won't work. And you can see the shininess on every single layer, meaning I'm pressing, but not pressing too much. And that's where it comes down to. So, if you guys want to print, you guys want to print effectively and all the time, constantly, you really have to watch out for your flow. And if you want to print faster, your flow is going to change because it is a constant. So it's being fed constantly over a period of time. That time might be perfect for a single quick print done, you know? But what if you have like 50 parts on your bed, let's say, or 2 parts? The flow is gonna be different actually. And there's a constant feed rate. Okay, we go back to feed rate, where it basically, it implies the whole entire speed. So if my flow, if I just crank up the speed to this printer, it still won't matter. I might under extrude. And you could end up seeing that, and no problem. But if suddenly your layers are not adhering, or you're not sticking to the bed, something's going wrong. It most likely is your flow and how much you are sending or telling your printer to send while it runs. And that is a percentage based off of your 100 millimeter E-steps. So if your E-steps are good, your flow can actually be calculated a lot better in the long run than in a short run where you're sending 97 millimeters every 100 millimeters asked. At that point, you're gonna need more over the long period of time, because suddenly you're reducing your backup and you're not sending enough to finish the print. Now, I can come back to this no problem, and I've done this millions of times. It's so simple. I don't know how many prints I've literally done. It's like, we basically have all sorts of prints. We can keep printing more things. It doesn't matter. You got Mario coins and everything. You to watch your flow. If you watch your flow, make sure that's good. You could literally just set it, forget it, and walk away. You'll always send that much. It is so important, I cannot stress it enough. So, let's see how the print's doing. It's still going. And it's using all the flow that I'm asking it to. It's using 100%. I have not changed absolutely anything. This has been from start to finish. And you know what? Once this is done, I'll just send the same exact thing again. And it would do the same exact thing. Now I can go to my slicer, literally, and just swap those models and push print. And it will work because it knows how much to send during a period of time. And I will never fail a print because of that aspect. It just won't do it. My printer knows to say under extrude, where I can bounce back and forth between model to model, and it works. I'm actually forcing it to under extrude a little bit, but it's just enough. It's not enough to like cause me a blob somewhere down the road, or bad layer lines as it tries to purge. So that's going to be your main problem and the main thing that you're going to have to watch. Otherwise, it's killer for your prints. And you might under extrude where it's very visual. Very visual. Sometimes it's really not. I'm under extruding right now, and you probably wouldn't even fully realize it. But that's the thing, isn't it? I'm also printing one of the same things with no infill, just walls, as you can see here, just walls, and then one with infill and one with just walls. And I'm also printing infill only every second layer over here. So this is going to be your main point of attack. If you want your prints so badly, you might want to check your flow and how it's being dealt. Now, to move faster, you're gonna have to literally watch out for your movement systems. I am using rollers. Entirely rollers, and I'm moving this fast. If you're using a linear rail system, you could probably shoot that thing so fast I don't even want to know. But I stuck to this because this is fast enough for me. I get my prints done, my clients are happy, and that's what matters, you know? My family's happy. I have so many prints, it's not even funny anymore. So, give me a second over here. I'm gonna show you some stuff. If you wanted, you could be showering yourself in prints that will just never fail. And it's Honestly, I have to say that you wouldn't be disappointed at all. I mean, we could just keep shoving more prints out here and more prints, and it became a problem where I suddenly have to, like, move out. I have to. I have... What is this? I have too many prints. I printed so many things. I don't know what to do anymore. This is ridiculous. So, I ask you, okay? I actually... Watch your flow. Your flow is so important, where it's going to either make it a workhorse, or you're going to want to chuck it out the window. Whichever one. This is just 3D printing. Watch your flow, guys. I'm not kidding. If you watch your flow, you're going to have prints after prints after prints, and you won't even have to worry. It's just going to go. Now you're going to have to realize that E-steps is about sending 100 millimeters of 1.75 filament. The printer understands that aspect too. And you must remember that the flow is not your E-steps. Now, if I put my flow to 125% and I did my E-steps are going to be wrong. It's a percentage of that dictated towards whatever size nozzle you're using. I've used 0.1 millimeter nozzles and had results about this. I've used 0.8 millimeter nozzles and had the same results at about this. Now, this is a 0.4 millimeter nozzle, which is the standard for all of you guys, and it comes automatic on an Ender system. Anyway, the most cheap, product-driven device, and you wonder why Prusas just work, right? Well, flow and E-steps and flow, because E-steps is a part of flow and flow is a part of E-steps, and your Z offset, okay? You could print at anything. I'll admit that right now, because I've done it. I've put 0.82 and I've printed like literally earlier today. I put 1.0. I printed perfectly fine. I put 1.80. I could print perfectly fine. The point is that it's going to change your Z offset and how it builds up over a period of time. Now you want to tell me I have to sand that? That little micro dot? I'll sand it. I don't care. What's that gonna do? What's that really gonna do? I get my prints out, I'm fine. Can see the shine. It's all good. So when you're looking at flow and how it's dictated, there's a reason why the Bamboo Labs X1 Carbon uses a LiDAR system to scan your flow before printing. And we'll even check your Z offset, your first layer, to make sure that that's actually good. I have found that if both are correct, you're showered in prints. It will never stop. But firmware has to be correct too. And everything has to be correct. Like, your firmware is going to dictate how the printer actually functions when it's functioning. And your flow and Z offset are based off of the way this builds. So if I send less flow, I need to squish more in order to get that good adhesion. But if I send more and don't squish as much, I still do the same exact thing. But there is a ratio in which you need more or less flow as you print. Otherwise, if that Z offset backs up that nozzle and you keep sending more and more and more, you're gonna purge and you might whack your print. You might do all sorts of things. But if you have it good, you could print for good.